Hello, welcome to the problem solving session. We're going to address this question today. We are going to use dimensional analysis to guess the formula. You probably know this formula already, so maybe you already known formula, right? The answer should be t equals to 2 pi square root of L over G. But we're going to pretend that we don't know, so we're going to pretend we don't know this, and we're going to try to come up with a formula like that. Before I get to the full answer, you should know that I won't be able to get this part, but we'll come very close. Okay, so let me adjust the thickness, so we're gonna be able to get that one. Okay, let's look at it. What we're looking at, the process is always kind of draw the system you're looking at to get an idea about. So this is a pendulum, and maybe some angle theta 0, you pull the angle, and then this pendulum kind of swings back and forth. So that one time is one period. Okay. So what this period can depend on? Well, if you look at various factors here, it can depend on, say, mass. It can depend on the length of the pendulum. Maybe it can depend on the force acting on it, which is mg. We already took care of the m, so this g is the new factor. So these are things we identify. Well, what else? It can there's angle of initial suspension, so it might depend on that also. So this is my variable I want to write. So I write a formula, and I'm going to assume that the t depends multiplicatively on that, but I just don't know with what factors, what exponent on each one of them. So t might depend on, I will say t proportional to maybe theta 0 to the power a, L to the power b, m to the power c, and g to the power d. We can write this now. This is dimensionless. This does not have any units. How do I know this doesn't have units? So if I look at in a circle, if I have this theta and this s and this r, so you know the s equals r theta. So if you solve for theta, so you have s over r. So this has the units of meter, and this one has unit of meter. So they cancel out. So this is a unitless. So we'll just say we don't know that, so we're going to ignore that and just absorb that in constant. So we can write this as t equals to some constant alpha, which is dimensionless, and L to the power b, m to the power c, u to the power d. And we need to find out what these guys are. Okay. All right. the basic principle is that units on this side must equal to the units on that side. Should be same. So we can work in the units, or we can work what is called dimensions. Or dimensions. Dimension on this side is dimension on that side. So let me just tell you what the dimension units are related. Is units, you might use some kind of SI units. So you have a length, a property length, and if you have a SI unit and dimension, so SI unit is meter for the length, and we'll use dimension just letter L, or sometimes like this. And if I have, say, mass, then you could use kilogram here, but in dimension just refer to m. So there's no confusion here. So you can get confused if you have a unit and dimension in same place, or m. So these are fundamental ones. So if I have a time, so you could use a second, and instead of s here you use t or t. Other units you can just similarly work out. So if I had an angle, say radian, but we don't, this is, dimension is none. Okay. Now let me erase this here. And get a clean slate here, so I can just show you there. So now here on the left side, you have a dimension of t to the power 1. I just keep track of the powers. On the other side is length to the power b, mass to the power c. Now g is acceleration, so it's length over time square. And if you have a power to the power d, that becomes length to the power d and time to the power 2d. Length can be simplified. So this alpha, length to the power b plus d, mass to the power c, and t to the power minus 2d. Now powers have to be equal on both sides. So this will mean b plus d has to be the 0 on this side for length, 0 this side, and on this side is b plus d. And for mass, 0 this side on c, so c equal to 0. It doesn't depend on mass. That's one of the interesting consequence of this. Like pendulums, when you swing different mass pendulum, they all swing with the same frequency as long as the length and g is the same. All pendulums of the same length swing with the same period, doesn't depend on mass. And if you look at the t, 1 this side and minus 2 this side, minus 2d. So this one I can solve immediately. So d equals to minus half. I can plug in here. This gives me b equals to half. So I got the b and d. So now we go back. We use these answers, and we go back to our expression, and so we get our prediction is t equals to some constant L to the power half, because this power is half, and then g to the power minus half, which you can write like some alpha square root of L over g. You can see that this is very close to the formula we expect. but we didn't have to do all the solving in Newton's equations. You have to solve, you have to make approximation. It's a very long calculation to get there, but we got there with very little work. Okay, we'll see you in the next video.